Hi friends, welcome to Sada Learning Hub. You are with me, Shada Shavrao. Today's session we are going to learn the different ways to define and instantiate and start a new thread. There are the two different ways to instantiate and start a new thread. Those are by extending thread class, and next one is by implementing the runnable interface. Now I am going to discuss about by extending the thread class. See here this example. I am creating a one class that is the main thread. I am extending from the thread class. If you see this one, I am creating a one class that is my thread. That my thread is extending from the thread class. Now I am override the run method. After that, I'm creating a one more class that is called thread_demo. In this thread_demo contains main method. I am creating a my thread object. My thread t is equal to new my thread. I'm called that run method by using the t dot start. T dot start means it is the starting of the thread. This is the starting of the thread. This is the one way of extending instantiate and start of the thread by using the extend keyword. This is the my thread extends thread. Now t dot start means we can start the thread. Now I can explain the different cases uh, to define a thread by extending the thread class. See case 1, thread scheduler. If multiple threads are waiting to execute, then which thread will be executed first is decided by the thread scheduler, which is a part of JVM. If multiple threads are waiting to execute, the which thread will be executed first, it is decided by the thread scheduler, which is a part of JVM. Which algorithm or behavior followed by the thread scheduler we can't expect exactly. It is the JVM vendor depends. Hence, in multi-threading examples, we can't accept exact execution order and exact output. Now, case number 2. Difference between t dot start and t dot run methods. Now I am explaining about t dot start method and t dot run method. See here, if you see this here I am calling the t dot start method. Here, this is the run method. In the case of t dot start, a new thread will be created, which is responsible for the executions of run method. But in the class of t dot run method, no new thread will be created, and run method will be executed just like a normal method by the main thread. In the above program, if we are replacing t dot start with t dot run method, it executes normally. See this one. Whenever we are calling the t dot start method, automatically this method will be called. If you put in place of t dot start method t dot run, it's like a normal method. It's not a thread. Next, case number 3. Importance of thread class start method. For every thread, the required mandatory activities like registering the thread with thread scheduler will takes care by the thread class start method, and programmer is responsible just to define the job of the thread inside the run method. That is start method acts as a best assistance to the programmer. If you see this start method, importance of start method, For each thread, the required mandatory activities like registering the thread with thread scheduler will takes care by the thread class start method, and programmer is responsible just to define the job of the thread inside run method. That is, the start method acts as a best assistance to the programmer. For example, what start method does means here the start method do three steps: registering the thread with thread scheduler, all other mandatory low level activities, and invoke a calling and run method. We can conclude that without executing the thread class start method, there is no chance of starting a new thread in Java. That is the importance of start method. Next, case number 4. If you are not overriding run method, if we are not overriding the run method, then thread class run method will be executed, which has empty implementation, and hence we won't get any output. For example, if you see this example, I'm creating a one class that is my thread. I'm extending from the thread class. I'm not implementing the run method. I'm creating a one more class that is thread demo. This is the main method of thread demo. I am calling the t dot start method. T dot start method automatically calls the run method of a thread class. Here in this class we are not implementing the run method. That's why thread class run method will be executed. The thread class run method is by default empty. It doesn't prints anything. It doesn't execute any statement in the run method. It is highly recommended to override run method. Otherwise, we don't go for multi-threading concept. Case number 5. Overriding of run method. We can override the run method, but the thread class start method always invokes no argument run method. The other overload run method we have to call explicitly, then only it will be executed just like normal method. If you see this example, if you see this example, we have we can overload run method, we can overload it. C means this is the run method, this is the run method with the single argument. If you overload the run method, but thread class start method always invokes no argument run method only. But if whenever you are calling the t dot start method, JVM calls only no arguments run method only. It invokes no argument run method only, and other overloaded run methods we have to call explicitly, then only it will be executed just like normal methods. If you want to run this method, we need to call explicitly for like t dot run of 3. It's executed normal flow of the program. Next, case number 6. Overriding of start method. If we override the start method, then our start method will be executed just like a normal method call, and no new threads will be started. If you override the start method, then our start method will be executed just like a normal method call, and no new threads will be started. If you see this example, I'm creating a one class. I am creating one method that is the start method. This is the run method. After that, I'm creating a thread demo. In the main method, I am calling t dot start method. Whenever we are calling the t dot start method, automatically it calls the run method. Sorry, automatically it calls the start method. Why? Because we are overriding the start method. That's why whenever we are call the t dot start method, it is checking from the here, it is available. That's why this method will be executed. Entire output produced by only main thread means here no thread will be started. Now I can explain the one more case. here is life cycle of thread. Life cycle of thread means once we create a thread object, then the thread is said to be a new state or bound state. See this, see this picture. Whenever we are creating a thread object, it is the new state or a bound state. Once we call the start method, then the thread will be entered into the ready or runnable state. Once we are start the t dot start method, once we are starting the thread will be goes into the ready or runnable state. If the thread scheduler allocates the CPU, then the thread will be entered into the running state. Whenever thread scheduler allocates the memory, it enters into the run running method, running state. Sorry. Once run method completes, then the thread will be entered into the dead stage. Whenever the run method invoked, after that the thread goes to dead stage. Next, one more case. After starting a thread, we are not allowed to restart the same thread once again. Otherwise, we will get the runtime exception saying illegal thread state exception. For example, thread is dead. After that, we are calling the try to call the method. In that situation, the compiler the it gives the runtime exception is illegal thread state exception. If you see this example, I can write one example here. I'm creating a thread. I'm starting the thread. It is the once again after few statements. Once again I'm starting the thread. T dot start. Here it is a valid. It is not valid. We will get the runtime exception. Illegal thread state exception. Next, I'm going to discuss about defining a thread by implementing the runnable interface. We are completing to instantiate or the thread by using the two ways. One is extending and another one is implementing. This is the second method, defining a thread by implementing the runnable interface. We can define a thread even by implementing runnable interface also. Runnable interface present in the java.lang package and contains only one method, run method. If you see this diagram, this is the our class. This is our class extends from the thread is extended from the runnable interface. This is an interface, this is the class, this is our class. This is the one approach to implement the threads. This is the another approach, directly our class is implementing from the runnable interface. If you see this example, if you see this example if you see this example, my thread implements runnable. I'm creating a one class, that is the my thread. My thread is implementing from the runnable. I am overriding the method that is the run method. After that, I'm creating a one more class. It contains a main method. I'm creating a thread for my thread class, and thread t is equal to new thread. Here r is the target runnable. After that, I'm starting the t dot start method. It executes fine. Here one more point is, we can't accept exact output of the exact output. We can't accept expect sorry we can't expect exact output of output, but there is a several possible outputs. So now see this here. I'm creating my runnable, r is equal to new my runnable. I am creating a thread. T1 is equal to new thread. I'm creating a one more thread. T2 is equal to new thread of R. It takes. Now I am discussing some cases here. The case one is T dot start method. A new thread will be created which is responsible for the executions of a thread class by using run method. Next, case number 2, T1 dot run method. No new threads will be created, but thread class run method will be executed just like a normal method. If you call the T dot start method, it will be executed the run method. If you call the T dot run method, no new thread will be created. It's like a normal execution of the method. If you call T2 dot start method, see this example. If you called T2 dot start method, new thread will be created which is responsible for executions of my runnable run method. If you call this, why? Because it takes the argument of my runnable objects. That's why it creates the new object. It creates a new it's create a new thread which is responsible for executions of my runnable run method. Now I'm going to one more case is if you are calling with T dot run method, no new thread will be created and my runnable run method will be executed just like a normal method. Just like a normal method. If you calling the T2 dot start method, it's like a normal method only. If you call R dot start method, see this is the R, my runnable object, R dot start method, we will get compile time error saying start method is not available in the main runnable class. If you calling R dot run method, no new thread will be created and my runnable class run method will be executed just like normal method only. I can explain one more time based on this example. If you see this example, this is the method, this is the class, my thread. I'm creating. If I am calling the t1 dot t1 dot start method, if you call the t1 dot start method, a new thread will be created which is responsible for the executions of the thread class run method. T1 means it is a thread class object. It calls the run method. Next, I'm calling t1 dot run method. If you call the t1 dot run method, no new thread will be created, but thread class run method will be executed just like a normal method call. If you calling t2 dot start, if you call the t2 dot start method, new thread will be created which is responsible for the executions of my runnable run method. If you call the t2 dot start, this is the t2, it is responsible to run the runnable class object. If you call t2 dot run method, no new thread will be created and the my runnable run method will be executed just like a normal flow. If you call r dot start method, we will get the compile time error saying start method is not available in my runnable class. Okay, it is not available in the my runnable class. If you call r dot run method, no new thread will be created and my runnable class run method will be executed just like a normal method call. Now I can explain best approaches to define a thread. Among the two ways of defining a thread, implements runnable approach is always recommended. In the first approach means extending from the thread. In the first approach, our class should always extend the thread class. There is no chance of extending any other classes, hence we are missing the benefit of inheritance. But in the second approach, While implementing the runnable interface, we can extend some other classes also. Hence, implements runnable mechanism is recommended to define a thread. Now, I can show you some of the thread class constructors. If you see here, thread t is equal to new thread. This is the default constructor. Now I am creating thread t is equal to runna new thread of runnable r. It is the parameterized constructor. It takes the runnable object like this. Thread t is equal to new thread string name. It is the parameterized constructor which takes a string data type. Runnable r string name. It takes a parameterized constructor. It takes the two arguments. One is the runnable and interface name, and another one is string. This is the one more constructor for the thread. It takes thread group thread thread group, comma string name. It is the parameterized constructor. It takes the two arguments. One is the thread group object and another one is the string object. Now this is the one more. It takes runnable r. It is also parameterized constructor. It takes the two parameters. One is thread group and another one is runnable. String string name. It is the parameterized constructor. It takes the three parameters. One is runnable, one is thread group, and another one is runnable, and another one is string name. Long stack size. STACKSIGT. It is the one more constructor, parameterized constructor. It takes the four parameters. One is thread group, and another one is runnable, and another one is string data type, and another one is long. These are the different constructors for the thread class. Finally, we are defining a thread by using we are initializing or a starting thread by using two ways. One is extending from the thread and another one is implementing from the runnable interface.
Thank you so much watching this video. Hope this lesson helpful to you. Keep watching our lessons. Keep writing to us. Do not forget subscribe our channel Sada Learning Hub because we have many sessions that would help you to develop our skills, and I will be back soon. Till then you take care. Bye bye.